Good evening, my excellent biology students. Hope we are doing fine. So, someone to please let me know if I'm audible enough. Lero kulibeka sound lero. Munakasettinga maningi. Munakasettinga maningi kanyimbo kanga. No, it's depressing. No, it's not giving. Lero kulizi. Lelo kulizi lelo. Today there's nothing. There's no sound today. Kulizililo munakasettinga maningi ka sound olero kuzankala chezi. So most people are sleeping. Most people are sleeping. I'm not seeing people. Let me try to share the link. So let's do this. Otherwise, how are we doing? Do you have power in your area? We had no power in my area since 24 hours yesterday. It came back today around I was told around 18. That's when power came in my area. So yeah, even up to now I'm still charging my things. Do you have power in your area? Benalimpo bagona. Oh, Benalimpo bagona Benalimpo. Wakonda ya 05 hivi. Yeah, Miss Josephine, you don't have power in your area. Miss Lee, you are the people. You are the people. So yeah. Oh, Limpo doesn't have bundles. Yeah. Yavutako ma bundles is on. Last time it was Miss Karen. So let's just wait for others to join. Then we can continue. So today I'm hoping to finish up this topic so that tomorrow I can look at health and diseases, and then the other day I can look at locomotion. So I remember I ended on I was describing the heart. So the description, I looked at the description of the heart. So today I have to look at the functions. Yeah. Yeah, this is where I'm supposed to start from. Functions of the heart parts. So let's just wait for others to join. Then we can start. Oglis really wants me to put take a sound. I'm even starting now. I'm even starting now. Okay, let me start. Someone is saying my phone is Azima. Yeah, I understand. I understand. So before I even continue, my excellent students, in our previous class we looked at the description. Yeah, I hope I'm audible. Please, someone to comment if I'm audible as I continue to explain. So we looked at the description of the heart. We know how the heart looks like. We know that the heart has got blood vessels, it has got valves, it has got chambers, and now we have to look at the functions of all these parts that are forming up the heart, and that's the thing that we're going to look at next. So we're going to start with chambers. So when you look at chambers, there are four chambers, okay? So chambers, what they do is that they receive blood. Chambers receive blood and they have walls which will pump the blood to the next chamber until it exits the heart. So when I was typing, I was missing out some words there, but what we need to know about chambers, let me just buy bundles. I've received a message that my bundles are almost done. So just a minute. Okay, done. Okay, okay. So I'm back. Okay, so as I was saying, chambers they receive blood, and when they receive blood, what we need to know is that chambers have got walls. Those walls they contract and relax, pumping that blood going into the next chamber until that blood exits or it exits the heart. So chambers simply receive blood, then they will pump it to the next chamber. Okay, that's what they do. And we know that on the left side, we've got two chambers, one on top, one down. On the right side, we also have two chambers, one on top, one down. I'm sure we know that. The two top chambers are known as atria. Okay, they are collectively called atria. And then the bottom two chambers, they are collectively called ventricles. So what they do is the same. They simply receive blood, then the walls will contract, pumping that blood, okay, out of the chambers. All right. And then the other function is that the right side of the heart, okay, RA, that's got RA stands for right atria, by the way. So if you see RA, that's right atria. So the right side of the heart, right atrium, and right ventricle, RV, right ventricle, handles deoxygenated blood and sends it to the lungs for oxygenation. So the right side of the heart, where there's the right atrium and the right ventricle, that side handles blood that does not contain oxygen, and it will send that blood which does not contain oxygen to the lungs for oxygenation. So the right side of the heart handles deoxygenated blood. Okay. And then the left side of the heart, which is left atrium and left ventricle, it handles oxygenated blood. Okay, it handles oxygenated blood and it sends it to the rest of the body. Okay, so the left side of the heart handles oxygenated blood while the right side handles deoxygenated blood. We need to know that, my excellent students. So the right side it handles deoxygenated, while the left side handles oxygenated blood. So under chambers, we just need to know that chambers they simply receive blood, and the chambers on the right side they handle deoxygenated blood, while those on the left side they handle oxygenated blood. And then we've got veins. Veins are attached to the heart. Okay, veins are attached to the heart, of which there are two types of veins that are attached to the heart, which are the pulmonary vein and the vena cava. Okay, so we've got the pulmonary vein and we also have the vena cava. These are the two veins that are attached to the heart. The pulmonary vein, which is on the left side, and the vena cava, which is on the right side. Now, If you look at the previous diagram, let me just go back. If you look at this diagram that we have here, okay, let me bring up a pointer. When it comes to the veins, we've got the pulmonary vein and we've got the vena cava. These are the two veins that we have, the pulmonary vein and the vena cava. And what they do is they bring blood to the heart. Now, when it comes to the vena cava, we've got the superior vena cava, which is this one, and we've got the inferior vena cava, which is down here. Okay, we've got the superior vena cava, which is this one, the one which is on the top part of the heart, and then we've got the inferior vena cava, which is down here. These are the two vena cavas, okay, the superior and the inferior. So vena cava kuli imodzi iri pamwamba inango iri pansi, okay, superior vena cava, inferior vena cava. And then for the pulmonary vein, we've got up, iri uku left, then iri uku inango right. Because we know that when it comes to the pulmonary vein, what it does is that it brings blood to the heart from the lungs. And if you look at the lungs, malungs ni abiri, imodzi iri ku left, inango iri ku right. So aya amene ali apa, aya ma pulmonary vein abiri aya, they are bringing blood from the right lung, bringing it to the heart. Okay, so these two, I am a pulmonary vein eye. They are bringing blood from the right lung. Okay, and then these two, they are bringing blood to the heart from the left lung. But the inlet is one, which is here. Okay, this is the inlet. So blood is going to come from the right lung, passing through this pulmonary vein, and then it will enter the heart through this left part. Or we're going to find the left atrium. And then again, with this side, we've got a pulmonary vena which are bringing blood from the left lung. Okay, so when it comes to the pulmonary vein, we've got those that are bringing blood from the right lung and those that are bringing blood from the left lung. And then when it comes to the vena cava, we've got the superior vena cava, okay, which is this one, and we also have the inferior vena cava, which is down there. So we need to know that. So now, having looked at this diagram, let me just go back. So we've got the superior vena cava. What does it do, the superior vena cava? So the superior vena cava collects deoxygenated blood from the upper body and brings it to the right atrium, where it then moves into the right ventricle and then to the lungs to trade in carbon dioxide for oxygen. So in simpler terms, the superior vena cava simply brings blood from the top part of the body to the heart, and that blood is deoxygenated. So the superior vena cava brings deoxygenated blood from the top part of the body, bringing it to the heart. Okay, that's what it does. That's the function of the superior vena cava. It simply brings deoxygenated blood from the top part of the body, bringing it to the heart. And then the inferior vena cava, on the other hand, it collects deoxygenated blood from the lower body and brings it to the right atrium, where it then moves into the right ventricle and then to the lungs to trade in carbon dioxide for oxygen. So the inferior vena cava simply brings deoxygenated blood from the lower part of the body, okay, taking it to the heart. And that blood is going to be received by the right atrium, of which it will then move into the right ventricle and eventually it will come out of the heart, go into the lungs to be oxygenated. Remember, the vena cava is on the right side. The right atrium is on the right side. The right ventricle is on the right side. And like we've said here under chambers, the right side of the heart handles deoxygenated blood. So blood that is received on the right side is eventually pumped out of the heart, going to the lungs, so that it can be oxygenated since it is deoxygenated. I hope I'm clear, my students. Someone to comment if I'm clear and if you are understanding so far. Are we good? Are we good? Are we okay? Are we okay? I hope I'm audible. I hope everything is clear. Okay. So now let's talk about the pulmonary vein. So the pulmonary vein, simple. Pulmonary vein simply receives oxygenated blood from the lungs and delivers it to the left atrium, okay, where it then enters the left ventricle to be circulated throughout the body. So the pulmonary vein, it is the one that transports oxygenated blood which is coming from the heart, okay. That blood which comes from the heart, from the lungs, it will pass through the pulmonary vein, going to the heart, okay. And then the left atrium will receive that oxygenated blood from the pulmonary vein, and then it will be pumped into the left ventricle, and then from the left ventricle it will be pumped out of the body, and it will pass through the aorta, going to other parts of the body, okay. Now let's look at arteries. So we've talked about veins, okay, of which there are two types of veins: pulmonary vein, vena cava. We've dealt with that. Now let's talk about arteries that are attached to the heart. So when it comes to arteries, like I said, let me go back to the diagram. So when it comes to arteries, we've got two kinds of arteries. Okay, we've got two kinds of arteries. We've got the aorta, okay, and we've got the pulmonary artery. We've got the aorta and the pulmonary artery. These are the two types of arteries that the heart has: the aorta and the pulmonary artery. So if you look at the pulmonary artery, I want you to pay attention to the pulmonary artery because I want to show you something. If you check the pulmonary artery, it takes blood to this side, which is the left side. Okay, it takes blood to this side, which is the left side, and it also takes blood to this side, which is the right side. Are you following? Okay, so it takes blood to this side, which is the left side. It also takes blood to this side, which is the right side. Why is it so? Because we know that the pulmonary artery transports deoxygenated blood, right? It transports deoxygenated blood, taking it where? To the lungs. So the blood that is being transported by the pulmonary artery, it does not contain oxygen. Therefore, it is taken to the lungs so that it can be oxygenated. So this pulmonary artery which is going to the left side, it is simply taking this blood to the left lung. And this pulmonary artery which is going on the right side, it is taking blood to the right lung so that it can be oxygenated. So that's the pulmonary artery, okay. And then the aorta, it is these to tube, the aorta. It supplies blood to all parts of the body. The blood that is being supplied by the aorta, it goes to all parts of the body, and this blood is what? It is oxygenated. So just sort of bringing back this diagram so we can look at it. So I hope it's clear enough for you to see. I hope it's clear enough for you to see. Okay, let me just put this on the corner. So I hope it's clear enough for you to see what we're talking about. So the aorta, it transports, oxygenated blood to different parts of the body, and the pulmonary artery transports deoxygenated blood to the lungs so that it can be oxygenated. The aorta is on the left side. So if you cannot see that it's on the left side, check the entrance of the aorta. The entrance is on the left side. You've seen? This is the entrance. It's on the left side. Or we're going to find the aortic semilunar valves. They've been given us here, the aortic semilunar valves. So the aorta, the entrance to the aorta, it is on the left side. Okay, so it's located on the left side. So blood is going to flow, going into the aorta, then to exit the heart, going to different parts of the body. And then when it comes to the pulmonary artery, it's on the right side. The entrance to the pulmonary artery, it's on the right side. So blood is going to enter and then it will go to the left lung, then the other blood will go to the right lung. So that's what we need to know when it comes to these two types of arteries. So let's go back to the arteries. Like, let me go back to the notes for the arteries. So arteries attached to the heart. So we've got the aorta, and I've already talked about the function of the aorta. I said the aorta, okay, is the largest blood vessel in the body and is responsible for delivering oxygenated blood to the body. So that's what the aorta does. It simply delivers oxygenated blood, meaning blood that contains oxygen. And then the pulmonary artery carries deoxygenated blood from the heart to the lungs. They are the only arteries in the body that carry deoxygenated blood. So the pulmonary artery are the only arteries in the body that are responsible for carrying deoxygenated blood, meaning other arteries, they simply carry oxygenated blood. The main pulmonary artery, which is the pulmonary trunk, leaves the right ventricle at the pulmonary valve, okay, which is also known as the pulmonary semilunar valve. It soon splits into the right and left pulmonary arteries. So we've got the right pulmonary artery and the left pulmonary artery. So the right pulmonary artery carries blood to the right lung. The left pulmonary artery carries blood to the left lung. Okay, so the vein said it soon splits into the right and left pulmonary arteries, which carry blood to each of the lungs, the one which is on the right side and the one which is on the left side. So when it comes to arteries, my students, that's what we need to know. We've got the aorta and the pulmonary artery. Those are the arteries attached to the heart. Okay. And then valves. When it comes to valves, all valves that the heart has, they perform the same function, which is they prevent the backflow of blood. Valves simply ensure that blood is flowing in one direction. So valves prevent the backflow of blood. And then when it comes to the septum, okay, with the septum, so the septum is a thin wall of tissue that separates the two sides of the heart, dividing the right and the left atria and left. Let me read that again. The septum is a thin wall, okay? The septum is a thin wall of tissue that separates the two sides of the heart, dividing the right and the left atria and ventricles. Its main functions are number one, separation. Okay, the main function of the septum is to separate the two sides to create the left side and the right side. So the septum keeps the oxygen rich blood from the left side of the heart separate from the oxygen poor blood on the right side. That's the first function of the septum. It ensures that the oxygenated blood which is on the left side, it is separated from the deoxygenated blood which is on the right side. Okay, that's what the septum does. It separates the two kinds of blood. The one which is oxygenated, that is on the left side, and the one which is deoxygenated on the right side. The septum separates. Okay, that's the first function. The second function is that it prevents what? Mixing. So prevention of mixing. The septum prevents the mixing of blood. Let me go back again. Oh yeah. So the septum prevents the mixing of blood from the two sides of the heart, ensuring that oxygen-rich blood is pumped into the body and oxygen poor blood is sent to the lungs. So the septum also prevents the mixing of blood, ensuring that the deoxygenated blood it is taken to the lungs, while the oxygenated blood is taken to all parts of the body. Okay, so that's the function of the septum. Are we clear so far when it comes to the septum, the valves, and the arteries? Are we clear? Tambono yawning. Are we clear? Are we clear? We can continue. If you've noticed, the class is smooth today. Eh? No issues, Ishan. We are on the right track. Now, I want us to talk about something here. Pumping of blood within the heart. Pumping of blood within the heart. So there was supposed to be a video actually. Okay. I hope I'll simplify this. Let me. No noise makers, mtintai. No noise makers. They are sleeping. So we know that the heart pumps blood around the body through blood vessels. So there is a process. There is a process that occurs within the heart. Okay, blood is pumped within the heart before it even comes out of the heart. There's that process that I want us to look at now. So that is pumping of blood within the heart. So the heart pumps blood by the contraction and relaxation of the heart muscles. We need to know that. The heart pumps blood by the contraction and relaxation of the heart muscles. That's how it pumps blood, by the contraction and relaxation of the heart muscles. Remember, I said the walls of the chambers, I said the chambers, they receive blood, and the walls of the chambers are going to contract to pump that blood going into the next chamber until finally the blood comes out of the heart. That's what I said. So the walls of the chambers, they contract. And when they contract, they pump that blood. They not only contract, but they also relax. Are you following? The walls of the chambers. So if I talk about the walls of the chambers, I'm referring to the walls of the atria and the walls of the ventricles. Okay. So when the chambers receive blood, for them to pump that blood, the walls have to contract. Okay. I hope we are together on that one. I hope we are together on that one. So the period of contraction of the heart is called systole. So when the walls of the heart contract, that is called systole. When the walls of the uh, heart contract, that is called systole. So systole, it's contraction. It's another term that is used. So the contraction of the heart, it is called systole. I repeat, the contraction of the walls of the heart, it is called systole. All right, Dialis, you're welcome. And what time was English? What time did class start for English? Kindly let me know on that one. Okay. So as I was saying, the contraction of the walls of the heart is called systole. During this period, the heart pumps blood into circulation. Okay. So during the period of systole, during this event known as systole, the walls of the heart, they pump blood. The heart pumps blood into circulation. So I'll try to draw I don't know if don't laugh at me. Yeah? I'm using a mouse, so I hope it will be something that will be clear for you to see. So we have the heart. Yeah. Then we've got this chamber here. We've got another chamber that. Then we have like that. Okay, you started at 22. Okay, noted. So this is my diagram for the heart. So we've got this chamber A. I'll also label this to be A. Then we've got B. Then I also have B. And then there are these valves. We just do this. Change the color. We've got these valves here, known as the tricuspid valves, and we've got these valves here known as the bicuspid. And then let me change the color. Let me select a bright color. So we've got these valves here, these valves here. Then we've got these ones here. Then even these ones here. These are the valves. So this is the heart. I hope it's clear. I hope you have a picture of what I'm trying to draw. We've got A, which are the atria, okay, or singular atrium, plural atria. Then we've got B, which are the ventricles. Now these four chambers, they have walls, of which we've said that the contraction of these walls is called systole. And we've also said that the heart pumps blood during this event known as systole. It pumps blood into what? Into circulation. So let's keep that in mind. Now, the period of relaxation of the heart is called diastole. So when the walls of the heart relax, that period it is called diastole. And during this period, the heart chambers are filled with blood. So during the period of systole, the chambers are pumping blood. During the period of diastole, the chambers are being filled up with blood. Let's continue. When atria contract, ventricles relax. When ventricles contract, atria relaxes. Now, here's what I'm going to do. I'll pick green. So we know this is the left side. This is the right side. Blood which enters, it is coming from where? The lungs. Blood that is entering on the left side, entering the atria, it is coming from where? The lungs. And this blood is oxygenated. When blood is entering on the left side, at the same time, my students, at the same time, blood is entering on the right side. And the blood that is entering on the right side, it is coming from different parts of the body. So the atria are receiving blood in this instant, in this moment. The atria are receiving blood. Chamber A are receiving blood. The two chambers which I have labeled A, they are receiving blood. The chamber which is on the left side, it is receiving blood from the lungs. The chamber which is on the right side, it is receiving blood from different parts of the body. So the two chambers which I have labeled A, they are both receiving blood at the same time, but they're just receiving different kinds of blood. Chamber A on the left, it is receiving oxygenated blood. Chamber A on the right, it is receiving deoxygenated blood. But both chambers are doing what? Receiving blood. Now, As the two chambers are receiving blood, here's what you need to know. As the two chambers, chamber A, as they are receiving blood, the walls are relaxed. They are relaxing because the two chambers are being filled up with blood. This period is known as the period of what? Diastole. The period of relaxation of the heart is called diastole. So since the walls of the atria are relaxing due to the fact that the atria are receiving blood, then that period it is known as atriodiastole. So atriodiastole is just the period when the atria are receiving blood. In the atria are the two chambers that I have labeled A. So when they are receiving blood, the walls are relaxing because the two chambers are being filled up with blood. I have even mentioned in this point, which is the third point, saying that during this period, the heart chambers are filled with what? With blood, of which in this case, it is the atria that are receiving blood. So therefore, they are being filled up with blood. And since they're being filled up with blood, the walls are doing what? Relaxing. And this period is known as atriodiastole. Now, as the two chambers that I have labeled A are receiving blood, the valves are closed. This valve on the right side, it is closed. This valve on the left side, it is also closed. So the two valves, they are closed. The valves between the atria and the ventricles are closed. This is atriodiastole. So during atriodiastole, the atria are receiving blood, the walls are relaxing, and the valves are closed. The valves between the atria and the ventricles are closed. I hope we are clear. I hope we're clear. Hope we're clear with what I'm communicating here. So during diastole, the chambers that I have labeled A are receiving blood. Okay, they are receiving blood. And as they are receiving blood, the valves, the bicuspid and the tricuspid valves are closed. Okay. And the walls of the atria are relaxing. That is what happens during atriodiastole. All right. I hope we're following. I hope we are following. I hope you're not dozing. Hello, wake up. Don't sleep. Don't sleep. I hope we are not dozing. I hope we're not dozing. Yeah. Almost done. Almost there. Almost there. 24 hours in Pafupi. We're almost there. Don't worry. We're almost there. So yeah, that's what happens during atriodiastole. Okay. The atria are receiving blood, the walls are relaxing, the bicuspid and the tricuspid valves are closed. Okay. Now, once the two chambers have been filled up with blood, once the atria are filled up with blood, they are now full, they are filled up with blood. What do you think will happen to the tricuspid valves and the bicuspid valves? I want us to interact now. What do you think will happen to the tricuspid valves and the bicuspid valves once the atria are filled with blood? What do you think will happen? What happens to the tricuspid valves and the bicuspid valves when the atria are filled up with blood? All right, wonderful. Oh, ndawantu angasikusira punzisa kanshi punsa sleeping audience. But kaklasi ka usiku kawama kapanga sense mwezi. Kapanga sense 23. Kapanga sense. It's quiet, you know. I've covered a lot of things pamene hapa. I've covered a lot of things. So what happens to the tricuspid and bicuspid valves? So J, for the valves, they do not close, they do not contract or relax. Valves, it's either they open or close. Okay, so for the valves, it's either they open or close. They do not contract or relax. For valves, it's either they open or close. So my question is, what will happen if the two chambers that I have labeled A are filled with blood? What happens to the tricuspid and bicuspid valves? So Dynas is saying they open and the blood will go to the ventricles, which is very true. Excellent. So when the two chambers that I have labeled A are filled up with blood, they are now full of blood. Then the tricuspid, of which the tricuspid is this one, and the bicuspid, which is this one, they are going to open. When they open, when the two valves open, which is the bicuspid and tricuspid valves, when they open, do you know what will happen? The walls of the atria are going to contract. When the tricuspid and bicuspid valves open, the walls of the atria are going to contract. And when the walls of the atria contract, what will happen? Blood will now be pumped going into the ventricles. Blood will now be pumped going into the ventricles on both sides. So when the atria, which I have labeled A, are filled with blood, then the tricuspid valves and the bicuspid valves are going to open. And when they open, the walls of the atria are going to contract, pumping the blood into the ventricles. Now, during this event is known as systole because there is contraction of the walls. But to be specific, it is known as atriosystole because it is the walls of the atria that are contracting. So we're going to term it atriosystole. So during atriosystole, what we're saying is that the walls of the atria are going to contract, pumping the blood into the ventricles. And for the blood to flow into the ventricles, it is because the bicuspid and the tricuspid valves are open. Okay, so during atriosystole, blood is going to flow going into the ventricles, which I have labeled B. Okay, yeah. So that's what happens during atriosystole. The walls of the atria are contracting, and the tricuspid and bicuspid valves are what? Open, allowing the blood to flow into the ventricles. Now, here's the catch. The chambers that I have labeled B, they are now receiving blood in this instant. They are now receiving blood. So since the chambers which I have labeled B are receiving blood, the walls of the chambers which I have labeled B are relaxing because chamber B are receiving blood. The ventricles, they are now the ones receiving blood. So since they're receiving blood, they're being filled up with blood, the walls are going to relax because they are receiving blood. And as the chambers which I have labeled B are receiving blood, these two valves, the aortic semilunar valve and the pulmonary semilunar valve, are closed. These two, this one which is between the left ventricle and the aorta, it is closed. Likewise, this valve which is between the right ventricle and the pulmonary artery, it is also closed. So as the ventricles which I have labeled B are receiving blood, the walls are relaxing, and as the walls are relaxing, the valves, these two top valves, they are closed. They are what? Closed. Okay. So what can we say here? What can we say? If you've noticed, we are saying that during atriosystole, the walls of the atria are contracting, right? And as the walls of the atria are contracting, they are pumping blood which is going into the ventricles which are the chambers that I have labeled B. And the bicuspid and tricuspid valves are open. So as these two chambers are receiving blood, what happens to the walls? They are relaxing, which makes this statement to be true. This statement. This statement is saying when atria contract, meaning when the walls of the atria contract, ventricles relax, meaning the walls of the ventricles are going to relax because they are receiving blood due to the contraction of the atria, which is allowing blood to be pumped into the ventricles. Fimveka, my students. No, fimveka vinagamba. Chamveka chizungu? Chamveka chizungu? Someone to comment nga chamveka chizungu. So when the atria contract, the ventricles relax, because when the atria are contracting, they are pumping blood into the ventricles, meaning the ventricles are receiving blood. And since the ventricles are receiving blood and they are being filled up with blood, the walls of the ventricles are going to relax. They'll relax because they are now receiving blood. Okay, are we following? Because this is the last time I'm talking about this. So I have to make sure that, yeah, we are following. So when atria contract, ventricles relax. Ventricles relax. When atria contract, ventricles relax. Now, here's another thing that I have to mention. During atriosystole, the walls of the atria are contracting. Yeah, the walls of the atria, they are contracting, pumping the blood into the ventricles, which I have labeled B. The ventricles are receiving blood and the walls are relaxing. Once the ventricles are filled up with blood, what happens to these two chambers, to these two valves? They are going to open. The pulmonary semilunar valves and the aortic semilunar valves are going to open, because now, once the ventricles have been filled up with blood, they are going to contract. Now, as the ventricles contract, let me do this. As the ventricles contract, the chambers which I have labeled B, as they contract, they are pumping blood out of the heart. As the ventricles contract, they are pumping blood out of the heart. And then these valves will open to allow that blood to come out of the heart. But what happens is these two valves, A tricuspid valve, and bicuspid valves, they are going to close. So when the ventricles are filled up with blood, they are full, they will contract, pumping that blood out of the heart. And it will come out through these blood vessels known as the aorta and the pulmonary vein, the pulmonary artery, sorry. So as the blood is coming out through these two valves, okay, these other valves are closed. They are closed. This is to prevent the backflow of blood. So as the ventricles contract, these two valves, the top two valves, they are going to open, allowing the blood to come out. While these two valves, they are going to close. Do you know why they close? Because at this moment, as these two chambers are contracting to pump blood out of the heart, the arteries are now receiving blood. Therefore, these two valves will have to close. So as the ventricles are contracting, pumping blood out of the heart, the arteries are receiving blood. Therefore, these two valves will have to close because the atria are now receiving blood. Okay. Which makes this other statement to be true. This statement, which is saying when ventricles contract, atria relax. So when the ventricles are contracting, let me get my pointer now. So when the ventricles are contracting, the atria are relaxing because they are now receiving blood. It's like a cycle. So when the ventricles are contracting, the atria are receiving blood. Therefore, their walls are going to be relaxing. Okay. I hope we're following. So now, when the right atrium and left atrium are filled with blood, from the vena cava and the pulmonary vein. Let me read that again. When the right atrium and left atrium are filled with blood from the vena cava and pulmonary vein, the atria contract while the ventricles relax, because in this case, the ventricles are receiving blood. This results into the pumping of the blood from the atria to the ventricles. During this period, the tricuspid and bicuspid valves open to allow blood passage from the atria to the ventricles. Nagwiraga? Okay. I know hapa hawezi tuzaoneka mshemushe, but I'll try to read them. Now, when the ventricles are filled with blood, they contract. The right ventricle pumps blood to the pulmonary artery, while the left ventricle to the aorta. During this period, the pulmonary and aortic semilunar valves open to allow blood passage, but the tricuspid and bicuspid valves close to prevent the backflow of blood from ventricles to atria. And this is what I was explaining. So then the ventricles relax again to receive blood from the atria. During this period, the pulmonary and aortic valves close to prevent the backflow of blood from the pulmonary artery and aorta to the ventricles. This is what I was talking about. So when the atria are receiving blood, the walls are relaxing, and these two valves are closed. The bicuspid and tricuspid valves, they are closed because the two atria are receiving blood. Once the atria are filled with blood, the tricuspid and bicuspid valves are going to open to allow blood to go into the ventricles, since now the walls of the atria are contracting. When the ventricles are receiving blood from the atria, the walls of the ventricles are relaxing, and the aortic and pulmonary semilunar valves are closed. Once the ventricles have been filled up with blood, they will contract. And in this moment, these two valves, the tricuspid and bicuspid valves, are going to close to prevent the backflow of blood. And in this moment again, the walls of the atria are relaxing because now the atria are receiving blood as the ventricles are contracting. So in other words, when the atria are relaxing, the ventricles are contracting. When the ventricles are relaxing, the atria are contracting. We need to keep that in mind. Okay. So the cycle continues, pumping blood in one direction. This is what we need to know under pumping of blood within the heart. Now we can talk about coronary heart diseases, of which I do not have much. So almost there. We are almost there. Coronary heart diseases. So we need to know that, the heart is a muscle, and it being a muscle, my students, it needs food and oxygen. Therefore, it has to be supplied with food and oxygen. The walls of the heart, they have to be supplied with what? Food and oxygen. And there's a special blood vessel that supplies, or that goes back to the heart to supply the walls of the heart with the food and oxygen. The name of that blood vessel, it is known as the coronary artery. The coronary artery, it is an artery that supplies the walls of the heart with the food and oxygen. Okay. The walls of the artery are supplied with blood, okay, which is oxygenated and contains food by the coronary artery. But when the coronary artery is now blocked by fatty materials, it will lead to a problem. And this problem is what we call CHD, coronary heart diseases. So coronary heart disease is commonly known as a heart attack. Okay, coronary heart diseases. It is commonly known as a heart attack. The heart needs oxygen and nutrients to carry out metabolic processes. Okay, because the muscle that makes up the heart is made up of cells. And in those cells, there are different processes that are taking place which will require oxygen and nutrients. So the heart needs oxygen and nutrients to carry out those metabolic processes. Now, the heart is not nourished by blood in the atria and ventricles, but contains special blood vessels called coronary arteries, which branch from the aorta. Okay, so what they are saying is that the heart, it is not nourished or it is not supplied with the food and the oxygen, or the oxygen and the nutrients, by the atria and the ventricles. It's not supplied with those things by the chambers. No. Instead, it is supplied with the food and the oxygen by a special blood vessel known as coronary artery, okay, or coronary arteries, because they are numerous. So the heart is not nourished by blood in the atria and ventricles, but contains special blood vessels called coronary arteries, which branch from the aorta. So the coronary arteries, they are branching off from the aorta, going back to the walls of the heart to supply it with food and oxygen. Now, coronary arteries can be blocked due to depositions in these vessels. So ngati mamukonda chakudya chemapizza, mashani, what, fatty materials, what. It may lead to such conditions, coronary heart diseases. Ati matenda yawolemera ndivyo vamakambira vantu. Matenda ya chinondo. Coronary heart diseases. Because you consume too much fats, you will find that it will lead to blockage of the coronary arteries. So when blocked, heart cells cannot receive oxygen now because they are blocked. So the cells that make up the walls of the heart cannot receive oxygen and nutrients. Therefore, they begin to die. This condition is called coronary heart disease. So I hope we know where this condition comes from. It simply comes from lack of supply of oxygen to the heart cells, leading them to die. Therefore, it will lead to the condition known as coronary heart disease. So blockage of the vessel is mainly caused by too much fats and cholesterol in the blood. Too much fat. So if you eat too much fats, obviously where is that fat going to go? Into the blood. So if there's too much of it in the blood, it may block the coronary arteries, which can now lead to coronary heart diseases. That is why ngati pali ma veg pemkudya paja, ngati pali ma veg mukasikamba zikomo. In fact, for the next week, jangu nche ma veg mukasikana chenyama, just say inenfunako che ma veg, just give me green things, just give me veggies. Mwakanako nyama this week, no nyama until mukalimbe exam. No eating chicken, no eating sausage, no eating whatever meat you can eat. Don't eat. Just eat vegetables, because now you've learned mwadya maningi nyama, mwadya maningi. So blockage of the vessel is mainly caused by too much fats and cholesterol in the blood. Okay. Now, causes of coronary heart diseases. We've already looked at one, which is too much intake of fatty foods, but there are other causes of coronary heart diseases. So one, high fat and lipid food intake. I've already talked about this. Too much intake of fatty materials or lipid food intake. Then smoking. Okay, smoking can also lead to this same condition known as coronary heart disease, because in smoke there's what we call tar. Tar can also lead to production of cholesterol that can block. Okay, at I can die vegetables only. Ni kudya chema vegetables, especially chihuahua. That's my favorite vegetable actually. Chihuahua. Said it as sedentary life. Mwizi wa sedentary life. Mwizi wa sedentary life. Who knows sedentary life? sedentary life mwiziba. In most of us we are like that. Ulace, too much ulace. Sedentary life, it's like a life which has got less activities. Mangala che kugona gona, kubeve kusumstakwa na ma exercise. Mumangala che kugona gona, kungo kudya che shani. Iyo, ndiye sedentary life. It's one of the causes. Make sure that you move around. Find something to do, like just make your body become active. That way you will help yourself. Okay, your heart should be, running. So sedentary life, it's a kind of lifestyle where an individual is just seated, they are lazing around, sleeping, that's sedentary life. Okay, then chronic stress. So stress can also cause what's this, coronary heart diseases. Stress, too much ma heartbreak ganza chepali ma partners so akamba na vandani, this time ali online kamba na vandani, sometimes mwagona che kugona che, sometimes ngatswashita respond gonani chabe, not stress, you're even stressed shan uko what, it will lead to coronary heart diseases, so to just prevent such diseases kugona chabe, don't even worry, just sleep. Okay, now having looked at the causes, prevention. How can you prevent? Prevention of coronary heart disease? Number one, reduce fat and lipid food intake. Reduce on those things. Even kambanati, diankon ma veg for 1 week, chab. 1 week. Nkankon pa fasting yano ma veg. For 1 week, chab. Too much intake. Mwimi anamatu mkaona pizza. Sumuza kutimzipaya. Mwena ngo mungazidiana pizza every day. Sumuziva kuti ivi vintu tiziononga. Sometimes ivi vintu vaso mwakanako che manje mungakane mwe pizza muntu abwera ati ani pizza mungakane mweni kuzivirane so mungakane vakamba reduce fat and lipid food intake, reduce once in a while. That is why even when you're eating your shima, ensure that sipali chenkuku paliko na maveji ngati pali chenkuku mwakana no inesini madias so I'm educated mwauza. I know that this thing, if I eat too much, especially amapanga these days manguku aya makula 2 weeks mulinayo nao busy, so busy na manguku yaso busy akamba pa reduce fat akamba apa noti manguku mashani nyama sausage what ngati maona chipambale palibe ndiyo palibe kasoti nchinamveshi yachinja mood yachinja no sindingazitia vaso muviganiza so avaniganzira chani vivanipasa hivi so mwakanako che sometimes mwakanako chimwamba ine nikudya maveg this week, I'm eating vegetables this week, just for 1 week. You see how your body will be active na mu exam brain isakankala sharp nakuza nine mamako na manzi. Quit smoking. So quit smoking, you have a self-explanatory. Quit smoking. Exercise frequently. Tupia mwaidabu isako sometimes yadabu wako tupia vama jumpa wakanshi yadabu wako chia vama jumpa wangatitako na skipping rope awa mwadabu isako tupi sometimes tupi mwachako ma exercise. If you're a guy mwachitako tuma push-ups to the 100 in a day mtima watamangako. It's important. Machako tuma exercise frequently. Machako register ku gym mwaendako che ku gym mwaendako pa mwaona not daily mungu onache vanzano pamachani mungu kamba abanawo iyai naye mwekasichani ma exercise. Mukaona muntu aposinga aone kamushi tupi anaisevenzera mambo kambata abanawo ashowinga muntu ma hips yake amaenda ku gym naye mkazienda mwatamangisako tupi. Exercise frequently ikamba exercise, it's important. Reduce stress nagamba kugona chenga tsfayanka gonani mwasamba kuganzaganiza no shani so akamba na vandani this is 04 shan akamba 22 sayanka ali kuti shan just sleep ngatsfayanka eat your shima with vegetables, sleep, wake up tomorrow Maybe you're even overthinking some of these things. You just overthink, stressing yourself. No, don't do that to yourself. Hmm? Don't do that to yourself. Reduce stress. And one way of reducing stress is what? Kugona chape, magona che. Mwabalako kwa sida. Not kungozivutisa mtima. Yeah, I'm even done. So that's one way of preventing coronary heart. Those are the ways, sorry, of preventing coronary heart diseases. So my homework that I can give you is to research on the coronary heart diseases, like the types. Oh, sorry. Well, you have to do like a research, like find out the examples, sorry, of coronary heart diseases. What are the examples of coronary heart diseases? That you can sleep, but your heart will still be paining. How? But how can you what? How can you sleep like that? Sure, you have to show yourself love. Self love is important. Self love, very important. Sometimes masula koche mungati bebe anachita mu masula koche unagona eh manje mungasona kambi che ka good night ngati wagona sona uzenkoni ka good night shuma kwia stress bwa. Sometimes vinango mwebala koche ni muntu na heavy, muntu na heavy. So don't stress yourself. Don't stress yourself. Simple as that. So we'll end here for tonight. Tomorrow we look at what's this? We look at health and diseases. You see that 23 hours in the smooth class ka? Ndawa ya yesterday pesically mchepa pamoja na pamoja, not even making progress, but we've managed to finish. Atinkani yaku moyo nyovutako kulibe but nyovuta mwandini nyovuta ologode brain yako sigona ingogani zapo che swakamba na vandani zona. Oh, God help us. God help us. That is why a single life is needed, but sometimes it's not. Otherwise, we'll end here for tonight, my excellent students. Unless there are questions. If not, we can call it a day. At whatever you're going through, eat first. Eat. Okay? Eat. Alright, Jay, I'm glad that you're enjoying the lesson. Famala Vipaya Zona. Okay, I'll send the link. I'll send the link once this live class is done. There's someone who wanted the song. That means of Nakanyim. I'd play the song. Otherwise, my students, okay, have a good night. Stroke good morning. We shall continue tomorrow as I look at health and diseases. All right, stay blessed.